geobyte.
Similarly, let us take the another important problem. Look at this problem. It is asking like this. An artillery piece of mass m1 fires a shell of mass m2 horizontally instantaneously after the firing. The ratio of kinetic energy of the artillery and that of the shell is, let K1 equal to kinetic energy of artillery and K2 equal to kinetic energy of shell. Okay. He is asking what is the value of K1 by K2. Okay. For that, let us take the general formula for kinetic energy. Kinetic energy K equal to half mv square. Can also be written as K equal to half mv whole square dividing by m, because the product of mass and velocity is the linear momentum. Linear momentum. Kinetic energy K equal to P square by 2m. Okay. But no, momentum remains constant. Linear momentum remains constant. Let me write in the other slide. Since linear momentum remains constant, remains constant, that is P is constant. P is constant. But kinetic energy K equal to P square by 2m. From this, I can conclude that since P is constant, kinetic energy is proportional to 1 by m, or kinetic energy is inversely proportional to mass. But look at the mass of the artillery. Mass of the artillery given m1 and mass of the shell is m2. Therefore, kinetic energy of the artillery dividing by kinetic energy of the shell is equal to, since kinetic energy is inversely proportional to mass, I can say that m2 by m1. So that is the answer. Look at the options. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, look at the another important problem asking like this. A solid circular disc of mass 50 kg rolls along a horizontal floor so that its center of mass has a speed of 0.4 meter per second. Mass of the solid circular disc is given 50 kg. Okay, it is rolling. You know, rolling motion is the combined motion of combination of translatory motion, translatory motion and rotary motion, rotary motion. Remember this point. This point already we have clearly discussed. Anyhow, the given problem is for rolling motion and its mass center is rotating or moving. The mass center speed of the mass center V is given 0.4 meter second power minus 1. The absolute value of work done on the disk to stop it. So here work done to stop the system is equal to translatory kinetic energy according to work energy theorem. Translatory kinetic energy plus rotatory kinetic energy according to work energy theorem. Let me write that point. According to according to work energy theorem. Okay. Here work equal to translatory kinetic energy half mv square, rotatory kinetic energy half I omega square. Let me take another slide. Here work energy equal to half mv square plus half I omega square. But as you know, I is the mass moment of inertia is equal to mk square. Omega equal to linear velocity dividing by radius. Okay. So work energy equal to work energy required for stopping the rolling motion half mv square plus half I equal to mk square into v square by r square. So from this I can write half mv square outside 1 plus 1 plus k square by r square. Where k is the radius of gyration, that is equal to d by 2 root 2 d by 2 root 2 for solid disk. K equal to this d by 2 I can write as radius dividing by root 2. Since k is r by root 2, k square equal to r square by 2 half mv square into 1 plus k square can be written as r square by 2 r square. This r square part is cancelling. Finally it is half m value. What is the m value given? Mass of the solid circular disk is 50, 50, 50, and the linear speed at the mass center 0.4, 0.4 whole square dividing by 1 plus 1 by 2 0.5, 0.5. You simplify this value, it is giving no 25 into zero point 0.4 whole square into 1.5, 1.5. You simplify this value for getting around 6 joules. That is the work energy required for stopping the rolling motion. Therefore, here 6 is answer. Understood clearly? 6 joules. Okay, na? Yes. Similarly, let us take the another important problem. Try to read this problem. It is asking like this. A block of mass 1 kg is pushed up a surface inclined to horizontal at an angle of 60 degrees by a force of 10 newtons parallel to the inclined surface. Look at the force. Force is applied parallel to the inclined surface. When the block is pushed up by 10 meters along inclined surface, the work done against the frictional force. Work done against the frictional force is how much? For the G value, 10 meter per second square. Coefficient of friction. Look at the coefficient of friction, 0.1. For that, let us take the another slide. This is the inclined surface. This is the base. This angle is given 60 degrees. Look at the weight. This is the weight. The weight is acting vertically downwards by magnitude mg. Let me mark the normal reaction. This is the normal reaction line. Then this is the 60 degrees. This self weight is developing two component of weights. It is mg cos 60 and this is the mg This is the mg sin 60. External force acts on the body equal to 10 newtons. But it is asking work done against the frictional force. Work done against the frictional force. Work done against the friction is equal to frictional force multiplied by normal reaction. Right? Frictional force equal to what? Frictional force equal to, right? Frictional force 8 minutes. Frictional force multiplied by displacement. Frictional force displacement by the displacement. Frictional force equal to what? Mu n into displacement. Mu into, look at the n value. This n value must be equal to mg cos 60. Mg cos 60 multiplied by the displacement of the body. Mu value given zero point 0.1. M value for the mass 1 kg only. Mass is 1 kg. G 10. G value 10. Cos 60 1 by 2. Cos 60 degrees 1 by 2. The displacement is given 10 meters. Displacement 10 meters. Simplify this part. It is this is 0.1 into 10. 0.11 to 5, 10 by 2, 5. It is equal to 5 joules. That is the work required against the friction or for overcoming the friction. So look at the options. Option B is absolutely correct. Understood clearly? This is very important problem. Very important problem. Right? Most expected problem in the competitive exams. Okay. Similarly, look at the another important question asking like this. A particle is placed at a point A. A particle, look at the point. This is the particle. This is the particle is placed at A of a frictionless track ABC as shown in figure. Frictionless. That means smooth surface. This is the this is maintaining the smooth surface. Means you need not to consider any frictional effect. Okay. It is gently pushed towards right. The speed of the particle when it reaches to the point B. What is the speed of the particle by the time that particle reaches to B? VB equal to how much? For the G value 10 meter per second square. Now apply the work energy theorem between the point A and B. So according to work energy theorem between A and B, between A and B, the total mechanical energy remains same at A and B. Therefore, the mechanical energy at A, I can say like this, total energy, otherwise, total energy of the particle at A is equal to total energy of the particle at B. That is the law of conservation of energy, right? So total energy means here kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. But since the particle is gently, particle is placed at the point A. Particle is placed at the point A means velocity of the particle at A equal to 0. If velocity of the particle at A is 0, kinetic energy of the particle at A is 0. Then UA equal to KB, K for kinetic energy, U for internal energy plus UV. Therefore, the kinetic energy at B is equal to the potential energy at A minus potential energy at B. That can be written like this. Kinetic energy at B equal to what? half mvv square is equal to mg mg into the mg एक मिनट mg za minus zb or ha minus hb. So this m part is cancelling, m is cancelling. Finally it is vb square by 2 is equal to g into the elevation at b is given 1 meter minus 0.5 meter, 1 minus 0.5 meter. vb square is equal to 2 into g into 0.5, 0.5. vb square equal to 2 into g value 10, g value 10, 0.5. It is equal to 10 only, 10 only. Therefore, the velocity of the particle by the time it reaches to b is root 10 meter per second. That is the answer. Okay. Is it option available? Yes, root 10. Look at the option B. Option B is absolutely correct. Okay.
Geobyte.